Part of finding the center of mass is becoming really familiar with the shape that you're trying to do. So this is a three-dimensional example, and it's being created from a rectangle that has a circle cut out of it, and then I'm going to give it a little roof over here. So kind of an odd shape that has a triangle, a rectangle, and a semicircle to keep track of. And this is an Inventor. They give us the center of gravity, so at the end of it, we can go back and check our answer. This is creating orthographic views of the object, just a way to put dimensions on it. So we're looking at the top of it, the front, and the side of it. So study that 3D view and try and make sense of those three orthographic views and how the dimensions are on there. And we're going to find the center of mass with respect to the origin. So 0, 0, 0, and you can see where the x, the y, and the z-axis are on this thing. So x to the right, y going up, and z coming forward in this case. Okay, so let's go ahead and just make a table, keeping track of everything in here. And there's a template for this table in your notes, but it's just for splitting everything up into pieces and finding the centroids of each pieces. You can add some color to it if that helps organize your thoughts. For this object, let's go ahead and we can start with the rectangle on the base of it. Okay, so we're not cutting out that semicircle. We're not worrying about the triangle, just the rectangular base. And we can get the volume and the centroids of this base. So halfway through the 10, halfway through the height of 1, and halfway through that 6. So that's the XYZ centroid of the rectangle and the volume of it. And then we're going to multiply the centroids by the volume for each piece. So y times volume and z times volume. Okay, so there is the rectangle. For the semicircle, we're going to treat this the same as the rectangle. The only difference being we will give it a negative volume. So to get the volume of this, we'll just take half of the area of a circle, and then we have to multiply it by the height. And we're making it negative because that semicircle is actually cut out. Now to find the centroids, we're measuring this with respect to the coordinate system. So you look up on the table, and you see that it's 4r over 3 pi from the base of the thing, but we're going to have to take that from the origin. So we're going forward 10 and then back 4r over 3 pi. So really make sure that you're measuring these things with respect to the coordinate system that's given. Now for the y direction, so the height is going to be the same height as our rectangle was. And the z direction, this thing is centered. And so we're just going to be going halfway through the 6 again. So make good diagrams and kind of label those dimensions and everything on the diagram. Okay, the last little pit is the triangle. So if we kind of isolate that piece and think about how it's oriented with respect to everything. For this last triangular piece, and really orient yourself with these orthographic views. So we have x is kind of the long dimension on this. That's where that 10 is going on. Z is coming forward. So if you're looking straight down at the top of it, that's what this view is. It's looking straight down at the top. So this is actually kind of the slanted roof of that triangle. And this is a Z direction. And the Y direction, that is coming up to the point. Okay, so if we're going to try and find where the centroid of this triangle is in the XYZ direction, in the x direction, we can look at this 5 dimension, and we can see we're halfway through the 5, so in the x direction it's going to be 2.5. And then in the z direction, we're coming halfway through the 6, so we're going to be at 3 in the z direction. And in the y direction, this is where we have to be careful. The triangle is kind of floating above the rectangle, right? So it's not just 1/3 h. We have to add the height of the rectangle and then 1/3 of the height of the triangle, which is 4 in this case. So this is going to be 1 plus 4 over 3. Okay, so the triangle, I guess we made this one blue. So the volume of this triangle is 1/2 base times width times height. So we're looking at equals 1/2 times 5. Do you see the 5 over there? And then we'll do the entire base, so 6. And then the height of this thing in the y direction is 4. So there's the volume of it. And then in the x direction, so that's coming out this way, that's going to be halfway through that 5. And in the z direction, it looks like everything is symmetrical in the z direction. So you'll notice that each of the pieces actually has the same centroid in the z direction. And then for the y direction, so y is the height of it. And for this one, we're going to go up the base of the rectangle. So this is going to be equal 1, the height of the rectangle, plus the height of the triangle divided by 3. So 1/3 times the height of that triangle. And that's, you can get the triangles off of the table. So the centroid is going to be h/3. And then for the base, it's just right in the center of the thing, and you can get that through symmetry too. Okay, so that's the end of the centroid. Now comes the moment of truth. So after we multiply this all out, we're going to add up each of our pieces and see if it matches what Inventor gave us for the coordinates. So equals z. And a lot of times it's really easy to get one of these dimensions wrong, and it's much easier to debug it in Excel. So in Excel, you can change one little number here or there. If you got the sign of it wrong or something, you can always go back and change one of these pieces of it. Okay, so we're adding up each of these little pieces. Let me get that equation. So the summation sign, that is what these 3 pieces are. And to get the overall centroid, we're going to take the sum of all of these and divide by, in this case, the total volume instead of the total area. So Control C, Control V, and just adding up all the volumes. Remember the semicircle, that is negative because that's a void. And for the x direction, we're going to add up all these little chunks and then divide by the sum of the total volume. And the same thing in the y direction. So adding up all these chunks divided by the total volume, and adding up all the little chunks divided by the total volume. And this is the moment of truth. Let me go find what Inventor gave us. Okay, so here we are back in Inventor, and we pulled up the eye properties, and the center of gravity should be 3.42 in the x direction. And think about that. So if this was 10 long, if it was just a rectangle, it would be 5, but it's heavy towards a triangle. So 3.45, that sounds right. And then for the height, for the y direction, so because it's top heavy, it's kind of right hovering above the rectangle here, and then it's symmetrical in the z direction. So if this was 6 across, it'll be 3, 3, 3. So it's 3 in the z direction. Let's go back to our Excel spreadsheet and see if that is what we got. So 3.5, 1.46, 3. Woohoo! We actually got everything in there right. So it actually does agree with what was going on. 3.45, 1.46. Let's see how many significant figures we matched. 3.452, 3.4515. Yeah, that's right. 467, 467, and 3. So yay, we got it right. And again, you probably won't get shapes like this right the first time through, so go back and think through the centroids of each part and eyeball where that thing should be, and make sure when you finally calculate it, it lands where you think it should land. So just be very familiar with the shapes, split it up into some common things, rectangles, triangles, circles, stuff you can look up in the table. Just take it one piece at a time. Okay, hope that helped.